Um, in this session, I am going to discuss under statistical process control special purpose control charts. Okay, there are many varieties of special purpose control charts, and before I discuss in detail some of the important special purpose control charts, let me highlight some of the important aspects while you use general purpose control charts. You are already aware of that what are the general purpose control charts under variables category, and in fact all these general purpose control charts are applicable in a manufacturing situation under the following conditions. So you please note them down. Like here, for whenever you use a general purpose control chart, we assume that the individual sample points are independent with one another. In other words, we assume that the samples which you were required to draw in order of maintaining the time order over the time periods, they are all independent with one another. That means the value you get in a particular sample is in no way it affects the values in the subsequent samples or the previous samples. Process mean remains constant. Center line is horizontal. This is another important assumptions we make. The third one is only the last shift, and if the process standard deviation is assumed to be sigma, that means the last shift sometimes we define as a shift with magnitude 1.5 sigma or greater than that, maybe 2 sigma, maybe 3 sigma. So always the shift in the process parameter is defined in terms of the sigma. So only large shift in process parameter value can be detected with substantial probability. As I have already mentioned that there are the two specific purpose of control charting. The first one is with the help of the control chart, a specific control chart, you will come to know at any given point in time whether the process has gone out of control. This is your first purpose, and the second purpose is if there is a shift in the process parameter value, the control chart must be able to detect it as early as possible, as quickly as possible. Now, in many cases, if you use the general purpose control charts or the so-called Shewhart control charts, you will find that this is its performance is very good as far as meeting the first objective is concerned, but in respect of meeting the second objective, its performance may not be that acceptable. So the state of the process doesn't have any explicit relationship with the performance of the process. That means what we try to do in many a time we'll be using the control chart, but then again in majority of the cases we say that the performance of a process is acceptable only when you are able to control the rejections in the process output to a substantial or to a reasonable level if we are able to control. Now, whenever you use a control chart, as such there is no relationship, explicit relationship of the state of the process, that means whether it's in control state or out of control state, with the performance of the process. In other words, we may assume that the process is in control. It doesn't necessarily mean that you will not be producing unacceptable output. When any one or more of the above conditions do not exist, special purpose control charts are recommended to be used. So I think it's made very clear that if someone asks you that under what conditions a special purpose control chart is to be used, so you will be able to highlight those special conditions. Now, given that the conditions in which the general purpose control chart charts are to be used, now supposing these conditions you are unable to meet, it's not under your control, so what to do? And you also you assume that the control chart is a viable tool, is an important tool for process control under special conditions. So what you need to do, that means you have to judge a special condition, and as per the special condition you come across, you need to use a type of control chart which is referred to as a special purpose control chart. Now, there are the researchers or the practitioners, they have already developed a number of such special purpose control charts. I am going to discuss a few of them. The first one I am going to discuss, that is referred to as the trend or the regression control chart. Is it okay? So first thing you must know that under what conditions this type of control chart is recommended to be used. This chart is used when the value of the quality characteristic increases or decreases over time due to reasons like tool wear, die wear, etc. So there are many cases. Till now we have assumed that the central line is a horizontal line, but in case there is a tool wear or in case there is a die wear, if you assume that the central line is horizontal, so your assumptions may not be correct. Hence, the central line is not horizontal to the x-axis. It has a slope upward or downward. Is it okay? Now, if you want to incorporate these aspects in the control chart, so what you need to do, that means you recommend a special purpose control chart called trend or the regression control chart. Now, initial and final values of the process mean, is it okay? There is a starting value, there is an ending value, as determined by the central line. Now, these values are determined with reference to the specification limits of the quality characteristics under consideration. That means whenever you draw a control chart, the control chart is drawn with respect to a specific quality characteristics. So, initial value and the final value of the process mean you need to specify, you must know. So this is a typical the trend chart. Let me explain it. That means here the horizontal line, no, this is the central line, it's not horizontal. So it has got a slope, the slope is small b, is it okay? It is a slope, and with the horizontal obviously, and it has got an intercept, and the intercept denoted as small a. Is it okay? Now, what you have in a typical 3 sigma control limits, and so what you have the upper control limit and the lower control limit. So the upper control limit is placed at 3 sigma plus 3 sigma from the central line, and similarly the lower control limit is placed at minus 3 sigma from say the central line. And you are already aware of that in R control chart, is it okay, or in X bar control chart you are always exposed to, and if you remember in the X bar control charts we have the upper control limit that is placed at from the central line A2 into R bar distance, is it okay, on the one side, and on the other side the LCL is placed from the central line at a distance of A2 r bar. So here it is not a horizontal line. It is the central line is having a slope of b, an intercept of a, okay, with the y-axis, that is the sample average, representing the sample average values. And so the upper control limit and the lower control limit, okay, you can determine, is it okay, when this distance is known, okay, A2 r bar or A2 r bar on the other side. Now you must specify for the given quality characteristic, say what is its upper specification limit and what is its lower specification limit. So this is a chart where a control chart where the upper control limit, lower control limit, the central line. Okay, so these three are compared actually with the upper specification limit as well as the lower specification limit. Is it okay? So you must know the location of the upper specification limit as well as the lower specification limit. Now this is the central line is given by this equation c equals to a plus bi, where a is equals to intercept. Is very simple. B is the slope and I is the sample number. Okay, so now you are aware of how to apply the principle of least squares. Okay, that means the fitted value you determine in such a way that the deviation from the mean, okay, the square of the deviation, the mean from the fitted value, is it okay, it's held minimum. So this is the principle of least squares. So this is the expressions, you can derive it. I don't need to derive this expression. This comes from applying the principle of least squares. So the intercept a is given by this formula, and the slope, the b, is given by this formula. Is it okay? So I suggest that you refer to the typical textbooks on the regression, on regression analysis, linear regression. So you will get these expressions for A as well as for B. X bar is the sample average, M is the number of samples. So whenever you use a sigma, that means sigma from I equals to say M, I equals to M to I equals to from I equals to 1 to M. Is it okay? So this is xi bar, actually this is xi bar, xi, x bar and I, all these values is the proper notations we have. So this is the expression. So what will be the upper control limit and the lower control limit for the regression control chart? That is A plus A2 r bar plus bi and A minus A2 r bar plus bi. Okay, if you refer to this figure, you will come to know the location of the upper control limit and the lower control limit. Is it okay? So this upper control limit and lower control limit, they are held parallel to the central line, and the central line is having a slope of b. While you use this chart, decision is to be taken regarding when the tool is to be replaced and how to determine the initial and final positions of the central line. So there is a slope. So obviously, what is happening actually, the due to tool wear or the die wear, obviously, the horizontal, there cannot be horizontal line. Is always, the central line will have a slope. Now there is a starting point, there is an ending point. That means it depends on what is the life of the tool. That means when you start with a new tool, okay, so you get the initial value, and when you replace the tool, okay, so you will get the final value of the central line. So when a new tool is to be used, the central line is set at 3 sigma distance above the LSL. Is it okay? So there must be certain norms, there must be certain rules. So what is that rule? That means whenever say the point at which the central line starts, that means referring to the first sample. So whenever you get the first sample, you are using the new tool, fresh. So the new tool is to be used when the central line is set at 3 sigma distance above the LSL. So this norm we follow, and when the central line is 3 sigma distance below the USL, the tool is replaced. Is it okay? So this rule we follow. Please refer to this particular control chart, and you will find that this is made very clear. Such and similar rules you may use while you use a train control chart. Okay. Now, so this is in short, say the specific features of a train control chart. This is also referred to as a regression control chart. And whenever you assume that the central line cannot be is a horizontal line, horizontal to the x-axis, and due to tool wear or the die wear, and it's a very common phenomenon in manufacturing situations. So obviously you have to use the regression chart or the regression control chart or the train control chart. Is it clear? And so I will set the numerical problems later on, right? And obviously when the concept is known, when the control chart related to a particular control chart, when the formulations of say upper control limit, lower control limit at the central line, these are known. So with respect to a typical let's say the numerical problems, we'll be again discussing this type of control chart. Now the next set of say control charts I'll be using under the special purpose category, that is modified and accept control charts. Till now you might have observed that while you use a control chart, there is no reference to the specification limits, or say related to quality characteristics. That identifications or the reference to the specification limit is very important, because we say the process is in control or the process has gone off control. This is one aspect, and we hope that if the process is in control, that means the process behavior, the process performance will be very consistent, and in course of time you will have enough control, substantial control on the process parameter value. And if you have say substantial control on the process parameter value, what is the expectation? Expectation is the process performance will be excellent. That means the number of say non-conforming say the units were produced as per the specifications, the number will be very less. So but here in this case what you try to do, that means first you use a modified control chart and you check that whether your performance of the control chart is such that the expected the number of non-conforming say the units is within control. That is the first condition you must arrive at. Okay, and when you arrive at these conditions, next you check that because of some reasons, suppose there is some say the excess the number of non-conforming units from the process which you are not going to accept, whether the control chart is able to detect that as an out of control condition, or you say that it must have say substantial or say the substantial value of beta. Okay, so first you use the modified control chart, and then you refer to the acceptance control charts, and in fact both these control charts must be used simultaneously. Now certain remarks I have made related to these two types of control charts. The first point is that these charts are used when the relationship between the process state, you know what is it, either in control state or out of control state, is it okay, or the process condition. So when the relationship between the process states and the process performance, how do you define process performance? Process proportion non-conforming or rejection. So this is to be explored. Is it okay? To what extent the state of the process is responsible for producing say non-conforming say the output. These charts are used when certain conditions are assured. Is it okay? It's not that at any point in time the process is newly installed and suddenly you start using this modified and accepted control charts. So before you, it may not be a good decision, and so before you start using these modified and acceptance control charts, certain conditions are to be met. What are these conditions? The process spread should be substantially less than the specification spread. So what is a process spread? Process spread is basically the distance between the upper natural tolerance limit and the lower natural tolerance limit. That means if you refer to in many a time, you assume that upper natural tolerance limit for a given process is at a distance of plus 3 sigma from the mean of the process, and similarly the lower natural tolerance limit is at a distance of minus sigma from the mean of the process. So, okay. Now the distance between the upper natural tolerance limit and the lower natural tolerance limit. So in most cases, you assume that if it is upper natural tolerance limits, you may assume it to be at plus 3 sigma from the mu, and the lower natural tolerance limit is at minus 3 sigma from the mu. So obviously, the process spread is plus 3 sigma on one side and plus 3 sigma on the other side. So total is 6 sigma. Is it okay? 6 into sigma. And what is the specification spread? Specification spread depends on the type of quality characteristic. So if it is quality characteristics and where the double specification limits are valid, then it is the distance between the upper specification limit and the lower specification limit. And if you deal with the physical characteristics, so it may be upper tolerance limit minus the lower tolerance limit. Is it okay? So the process spread should be substantially less than the specification spread. Second condition is, I have already explained what is this 6 into sigma. Is it okay? Should be substantially less than USL minus LSL when the control limits are set at plus minus 3 sigma limits from the central line. That means the process mean. Central line actually indicates the process mean. So this part already I have explained. There may be changes in the value of the process mean, which is unavoidable within a range between upper and lower limits. That means suppose the mean is 100. Okay, so the process mean is assumed to be 100. That is mu. Now mu itself may be a random variable. That means depending on the condition of the process, or if there is the drifting in the process. Okay, so you say that the process mean I will allow in order to have an acceptable performance from the process, say between 80 to 60 or say between 80 to 120, and on an average on I will assume it to be around 100. Is it okay? So you set the upper limit, you set the the lower limit of the process mean. Is it okay? So this is you have to pre-specify these values. That means your knowledge about the process should be substantial, and given a particular quality characteristics, given a process, you must be able to specify the upper value of the process mean as well as the lower value. Okay. Now the type 1 error probability of the control chart is specified. What is type 1 error? I have already mentioned. That means the process is assumed to be say under is gone out of control, but actually it is in control. Okay, so that is basically the type 1 error. Now what is this type 1 error probability? That is alpha. Now so distribution of individual values, this is your distribution of the individual values. Is it okay? I am assuming that that individual x value is normally distributed, and that is the case in a running production system in respect of say particular quality characteristics. So what you find over here, that means x will this value, that means there will be mean somewhere here. Is it okay? So the mean value is the lowest value you assume somewhere here, and the highest value of mean is the upper, mu u and mu l. Is it okay? Now there is a shifting. Now how do you specify the upper limit as well as the lower limit of the process mean such that the proportion non-conforming is restricted to delta? Getting my point? So suppose you have say the process right now over here. Now it is suppose an upward drift. Is it okay? So ultimately it will be, all these values will be changing to the higher sides, these values, and whenever it reaches this value, so it becomes mu u, you will find that this proportion, is it okay, beyond upper specification limit, this is the proportion non-conforming. Now you determine the value of mu u in such a way that the proportion non-conforming is restricted to delta. And similarly, suppose there is a downward drift, that means on this side the mean value may move, and ultimately so the lowest value you determine, that is mu l, in such a way that the proportion non-conforming, that means area under the curve beyond LSL, that is restricted to delta. So delta you specify, and you need to determine under these conditions what could be my expressions for upper control limit and the lower control limit. So obviously you must know that what is the distribution of the sample mean, that is x bar. Is it okay? So what do you try to do? Now you have the lower limit for mu, that is mu l. If you have the upper limit, is it okay, for the mu, that is mu u, and then you consider the distribution of x bar. Is it okay? So here what we are assuming, when you consider the individual value x, so this is the standard deviation is sigma, whereas here the standard deviation will be sigma upon root n as per the central limit theorem. Is it okay? So obviously we specify this is the lower control limit, and we specify this as the upper control limit. Is it okay? Now whenever you draw a control chart, there has to be there will be always the probability of making type say 1 error. So this probability is alpha. So here this area under this curve, this is referred to as alpha, and similarly this area under this curve, that means when the mean value is at mu l, obviously this area is alpha, it is beyond LCL. Now what is this distance? That means standard distance is z alpha, is it okay, into sigma upon root n. Similarly this distance will be Z alpha into sigma upon root n. Is it okay? So now what you try to do, that means you write down the set of equation. So if you just refer to this the two figures, you will find that mu L is LSL plus Z delta into sigma. Similarly, mu U is USL minus Z delta into sigma. Is it okay? And so the UCL is ultimately mu U plus Z alpha into sigma by root n, and LCL is mu L minus Z alpha sigma upon root n. So you have ultimately, when you consider both these sets of equations, so you have the upper control limit is equals to upper specification limit minus this expression into sigma, and the lower control limit is equals to LSL plus Z delta minus Z alpha divided by root n. N is the sample size into sigma. Now this sigma is basically the process standard deviation. So if you already use the R control chart, so obviously R bar will be known, D2 is also known, dt is a function of n. So you can have an estimate of sigma hat. So if you use R control chart, instead suppose you use S control chart, obviously S bar will be known. Is it okay? And the C4, that value is again is a function of say n or the sample size. So you get the value of C4 and you get an estimate of sigma hat. So from this you get from the R chart and this you get from the S chart. Now before I close the session, so just I want to highlight one important point. That means this modified control chart you use only when it is assured that the process is in statistical control. So this is to be assured. And how do you know that the process is in statistical control? As I have already mentioned, that if the process spread is less than substantially less than the specification spread, and the process is centered, that is very important point. So please note it down that sometimes we seek a condition called centering of the process. What is the centering of the process? That means the process mean is coinciding with the nominal value or the target value of the quality characteristics. Is it okay? That means you say that mu is approximately equal to, is almost same as m. M is the nominal value. Nominal value is the desired value. So suppose you have a two-sided specification limits case. So obviously m is assumed to be the midpoint between the USL and LSL. In other words, USL plus LSL divided by 2. So this centering of the process, this condition is to be arrived at, and then you check that whether the process spread is substantially less than the specification spread. So if these two conditions are assured, then you can use the modified control chart. One of the most important, the special purpose control charts we use. Is it okay? So the other control charts, like say acceptance control charts and so the Q sum control charts, we'll be using in the subsequent session.